Okay, cool. So we're going to add our exponents here with our product rule. So my 5 remains the same, and 7 plus 6 is going to give me 13. We would have 5 to the 13th power be your answer. Okay, it's asking us just to simplify there. Number 2, also asking us to simplify. And we have 10 to the 9th over 10 to the 4th. And what rule are we using here? We're using your quotient rule because we have division. All right, with your quotient rule, remember we subtract our exponents. All right, so when we subtract these exponents, we have to have the same base. So if we look here in number 2, we have the same base, which is 10. All right, and remember, you read a book from left to right and top to bottom. Same thing, we subtract top to bottom. It'll be 10 raised to the 9 minus 4, and 9 minus 4 will give you what? 5. So you have 10 to the 5th power. So we have product rule, quotient rule. All right. So number 3. It says which of the following will give the same value as the expression below? So the expression they have here is x to the 6th over x to the negative 4. Okay. Now with this one, we have a lot going on. All right. We've got our quotient rule because we have division, and we also have this negative down here. And that negative probably is going to throw some of you off. Okay. So what I would do is I would go ahead and move negative to top to make positive. All right, so we're going to make that positive by moving that to the top. Okay, so when I do that, it's going to look like this. I'll have, once I flip that, I'm going to have x to the 6th, x to the 4th. And when they're side by side like that, that means that they are being multiplied. Okay, and when they're being multiplied, what rule do we do now? We do the product rule. Okay, once they're being multiplied, we do the product rule. So our product rule, as long as we have the same base, and we do, which is x raised to the 6 plus 4, and 6 plus 4 is 10. Let's look at number 4. It says simplify, and we're simplifying 3 to the 6th times 3 squared times 3. Okay. So we have multiplication, which is the product rule. And with the product rule, what do we do with our exponents? We're going to add them. So the thing we add our exponents, some of you are going to forget this one. If you have a number by itself, what is it raised to? What power? There's the power of 1. Okay. So do we have a similar base here? Yes. 3, 3, and 3. So we're going to have 3 raised to the 6 plus 2 plus 1. And what is 6 plus 2 plus 1? 9. So 3 to the 9th power. Any questions so far? Okay. All right, number 5. Which expression shows another way to write 3 to the 3rd raised to the 2nd power? Here we're going to have our power to a power rule. Okay, so our power to a power rule means we're going to multiply our exponents. All right, so look at my exponents here. I'm going to multiply those. So we're going to have 3 raised to the 3. Huh? No, that was kind of an arrow drawn showing to the 3 times 2. What is 3 times 2? 6. So you had 3 to the 6th power. That's not what your question is asking. Your question is asking which expression shows another way to write that. So would that be A, B, C, or D? You look at those. It's going to be D, because we're multiplying with our power to a power rule. So that would be D. If I'm going too fast, let me know. I can slow down. We can talk about certain ones that might be confusing. If something's really confusing you, let me know so we can go over it. 6 says, which of the following expressions is not equivalent to 1 over 125? Okay, so we're going to look at those 4 expressions. Okay, you need to know which one is not. What we're going to have to do on those, we're going to go through each one of those, okay, and see which one is different. Which means we're going to have to look through our rules, and all of them are multiplication. There's our product rule. Okay, so if we look at A is 5 to the 4th times 5 to the negative 2. Okay, so before I do anything here, I can do my product rule. Okay, if I do my product rule, I have similar bases. I'm going to have 5 to the 4 plus negative 2. And what is 4 plus negative 2? 4 plus negative 2 is the same as 4 minus 2, which is just 2. So this will be 5 squared. And what's 5 squared? That's 5 times 5, which will give you what? 25. Okay? So that one's definitely not equivalent. All right? So look at B. We have 5 to the negative 3 times 5 to the 5th. Again, product rule because we're doing multiplication. We have 5 to the negative 3 plus 5. What's negative 3 plus 5? It's the same as 5 minus 3. Be 2. So that would also be 5 squared. C is our product rule, which would be 5 to the 3rd times 5 to the negative 5th. This is going to be 5 to the 3 plus negative 5. What's 3 plus negative 5? It's kind of like if you owe somebody $5 and you pay them 3. What do you owe them? You owe them $2, it would be negative 2. So do 5 to the negative 2 But to change that to a positive exponent, what do I have to do? How do we make negative exponents into a positive? We just flip it. Okay, so change to a positive, we just flip it. So it's going to be 1 over 5 squared. Okay. And then the last one, we have 5 squared times 5 to the negative 5, which would be 5 to the 2 plus negative 5. What's 2 plus negative 5? Kind of the same deal. You owe somebody $5, you pay them 2. How much you owe them? 3. So it'll be 5 to the negative 3. And to change it to a positive, we flip it. 1 over 5 to the third, and that one would be 1 over 125. I think they wrote that question wrong. It should be which of the following is equivalent to. But if we were choosing as not, your answer would be A, B, and C. All three of those are not equivalent because 5 to the third power is 125. So 6, your answer would be A, B, and C. All right, 7. 7 is actually asking us which expression is equivalent to, we have 7 to the negative 3 raised to the third power. This is our also power to a power rule. Okay, which means we're going to multiply our exponents. So we multiply our exponents here. We're going to have 7 to the negative 3 times 3. What's negative 3 times 3? A negative times a positive is a negative, okay? And then 3 times 3 is 9. So it's going to be 7 to the negative 9. And how do we make that negative exponent a positive? What do? We flip it. So when I flip that, my answer, I'll put it over here so it'll fit. 1 over 7 to the 9 will be your answer. And for that one would be A. All right, let's look at number 8. Number 8 says, which of the following is an irrational number? What's an irrational number? Kind of think about it. It's a number that really doesn't make a lot of sense. Okay? So a rational number is always going to be like a whole number, an integer, your natural numbers. Okay? It's going to be a terminating decimal. All right? So if we look at these, A, square root of 81. Well, square root of 81 rational or irrational? It's rational. Because square root of 81, this equals 9. Okay, it equals a whole number. Look at B, square root of 25, rational or irrational? That's rational, because square root of 25 is going to give me 5. That's also a whole number. C, square root of 5, is 5 a perfect square? No, 5 is a prime number. So this isn't a perfect square, which means this is going to have some long decimal. Okay? So I know that C is irrational. And that will be your answer there, because D, the square root of 16, is 4. Okay? So your answer for 8 would be C. C will be irrational. Because these other three, we can put those in a calculator and it'll give us whole numbers. So all of those are perfect squares. All right. 9 says, which is equivalent to 4 to the third times 4 to the negative 3. What rule do we got going on here? They're being multiplied, which is our what? It's a product rule. With our product rule, remember we add our exponents. All right. So we're going to have 4 to the 3 plus negative 3. What is 3 plus negative 3? Is what? 0. They're opposites. Opposite numbers always add up to 0. So 4 to the 0 power, or anything to the 0 power, is automatically what? 1. So your answer for 9 would be 1, and you would find, or no, it says what is equivalent, but they don't have any multiple choice there. So the answer would just be 1 for number 9. All right, 10. 10's a good tricky one. That might stump some of you. We got 2 to the 5th times 2 to the 5th over 2 to the 4th. Okay. This is probably one of those problems that when a lot of you look at it, you're probably just like, there's way too much going on here. I don't know where to start. Okay. Well, again, just kind of like you read a book. All right. And I'm not an English guy. I don't like reading. Okay. Sorry. You heard teachers say they don't like to read. I hate to read. But anyway, you read top to bottom, left to right. So in math, I always say a good practice is to start at the top like you would with the book. So let's start up here and simplify up here at the top. And what we got going on at the top, okay, is our product rule. And with our product rule, what are we going to do with our exponents? We're going to add them, okay? So with our product rule at the top, we're going to add those exponents. First, I have 2 to the 5th plus 5. So what is 5 plus 5? 10. So your numerator is 2 to the 10, okay? So I've got my numerator, 2 to the 10th, and I'm going to leave it over 2 to the 4th. Now, what rule do we have going on here with our fraction, which is the same as division, which is going to be which rule? The quotient rule. And with our quotient rule, what do we do with our exponents? We're going to subtract them. So 2 to the 10th minus 4. And again, I started with 10 because just like you read a book, top to bottom, 10 minus 4. Okay? So we have 10 minus 4, which gives us what? 2 to the 6th power. So your final answer will be 2 to the 6th power. Okay? So it looks complicated, but if you break it down, all right, break it down, do it piece by piece, you can really simplify that. Okay? If you didn't need to do all these steps, that's fine too. Okay, y'all hear me say this a lot this year. Make math your own. Do math how you understand it. Don't get stuck on trying to do it how I do it or try to do it how your neighbor does it. If you take this whole page and fill this whole page full of work to get an answer, and it takes me 2 lines to get the same answer, our answers are the same, who's wrong? Nobody. You may have more work than me. That's fine. That's how you understand it. That's okay. Okay? So don't get stuck on trying to do it a certain way. Do it how you understand it. If there's a certain way you understand it, roll with it. Okay? 11. Don't we have to write 11 down? I don't know if we even write 11 down. Look at number 11. Which of the following numbers is irrational? Negative 2/3, square root of 81. Big long decimal there, or 0.0075. It's irrational, which means it doesn't make sense. Which one? Why C? It's a bunch of numbers, and it's got our little 3 dots telling me it goes on forever. It never stops. A, we can rationalize A because it's a fraction. Okay, B, square root of 81 is 9. And D, that's a terminating decimal. That decimal is going to end. It's just 0.0075. But C goes on and on and on and on and on forever. Okay, so C is going to be your irrational number. All right. Let's look at 12. The number square root of 32 lies between which two integers? Okay, so we're estimating square roots for number 12. This is going back to the last unit. Okay. Now we estimated square roots. We had to think about numbers that were perfect squares. Okay. So if I take and I put 32 down here, we're going to think about a perfect square less than 32 and a perfect square greater than 32. So our perfect squares are 1, because 1 times 1 is 1. 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9. 9 is a perfect square. 4 times 4 is 16. 16 is a perfect square. 5 times 5 is 25. So 25 is a perfect square. So 25 is pretty close to 32. We're going to 25 here. And then 6 times 6 is 36. So 36 is going to be our perfect square that's greater than 32. Okay? So we're estimating. It's asking which the number 232 lies between which two integers. So the square root of 25 is 5, and the square root of 36 is 6. So I know the square root of 32 is going to be about 5 point something, because it's in between these numbers. It has to be my decimal and something else. Does it ask us to estimate that number? God bless you. Mm-hmm. No, the question just asks us what two integers that lie between. So your answer for number 12 would be it lies between 5 and 6. Okay. So you're looking at this number and you're thinking of trying to find the perfect square that's less than and the closest one that's greater than. Okay, and that number's going to lie between there. So we know the square root of 32 will be about 5 point something, which means it's between 5 and 6. Okay. $13. Rhett fed 1/9 of his chickens at a farm. What's the decimal that is equal to the fraction of Rhett's chickens? How do you change a fraction to a decimal? How are we going to change that fraction to a decimal? He fed 1/9 of them. Okay, and we're going to change this to a decimal. Now, I'm going to give you another hint. I'm going to use reading again. Okay, and like I said, I don't like to read, but there's sometimes we can use it to help us in math. And I don't know why, but it seems like all students have trouble with fractions of decimals. So we don't know which number goes inside the house and which number goes outside the house. Okay, so we're going to read this. And when I read this, I can say 1/9, okay? But I can also see that I know this fraction looks like a division sign, right? And if I read this a different way, I can read this as 1 divided by 9. So I want you all to watch as I write this and read this to myself, okay? So I'm going to write, this is 1 divided by 9, okay? You all see how I kind of use my words to draw my house, divided by, and that'll tell you which number goes in the house. Also, it'll tell you how to type that into the calculator. 1 divided by 9. It should type it like that in your calculator. Okay? So if you read this to yourself and you read this top to bottom, it'll actually tell you which numbers go where versus you sit there looking at it going, oh, where does this go? And then you might get it wrong. Okay? So when we do 1 divided by 9, we're going to get, clear all. There we go. You're going to get 0.11111, and just going to keep repeating. How do we write repeated decimals? What do we put over top of them? A line. So you don't have to write all that. You could just write 0.11 with a line over it. I think that's repeating. Okay. So the next one, what is the approximate value of the point on the number line? And it's asking for the square root of 60. Okay, or 160, I'm sorry. So the square root of 160, and we're approximating. Now the one thing that's really good about this question, if you notice all four of those dots are in between four different sets of numbers. So really all we have to do is figure out what two numbers it's between. That's going to give us our answer. Some of you are going to go in depth and try to really work this out, but you don't have to. Okay, so the square root of 160, if I think about my perfect squares that I'm going to put this in between, I know that one less is 144 because 12 times 12 is 144, and then 169 because 13 times 13 is 169. So the square root of 144 is 12. Square root of 169 is 13. That question's wrong. Anyway, it's 160, right? That's what your all says, right? Yeah, that question's wrong. They got their numbers wrong, whoever made this. Anyway, it's none of those points because the square root of 160 is going to be between 12 and 13. Okay, so the first set should be 12 and 13. So we know this is approximately 12 point something, and this is going to be between 12 and 13. Okay. All right. 15 says estimate the square root of 90. Well, just like we've done these last couple of questions. Okay. We got to think about our perfect squares. What two perfect squares does 90 lie between? So if you think about one of the examples we did earlier, I told you guys that the square root of 81 was 9. So I know that 81 is going to be a perfect square. Okay. So 9 times 9 is 81. So what's 10 times 10? That's going to be the one that's above it. It's 100. All right. So I know the square root of 81 is 9. And the square root of 100 is 10. So my answer is going to be about 9 point something. Okay. Now we have to figure out that something. So how far from 90 is 81? Do 90 minus 81, you get 9. So we know this is 9. And then 100 minus 90 is 10. So this number is kind of in the middle. It's not exactly in the middle, but it's pretty close. Okay. It's closer to 81 than it is 100. So we could say this number is approximately 9.5. And you could also say it's approximately 9.4. Okay. Either or, I would accept those. I wouldn't accept 9.6 because we know that 90 is for sure closer to 81. If you said 9.6, you would say it's close, it's halfway, it's over halfway to 100, and it's not. Okay, so it's either 9.5 or 9.4. All right, either, and like I said, it says estimate, so we're not looking for an exact answer. Okay. 16. What is the decimal representation of 20 over 7? Again, we're having a fraction, and we're changing it to a decimal. If you read that to yourself from top to bottom, okay, it'll be 20 divided by 7, okay, or 20 divided by 7. That's how it would go in your calculator. So if you put that in your calculator, you will get 2.857, and we'll just round it. We'll just kind of leave it there. I don't need to write all that down. Hopefully that little trick there kind of helps you all know which number goes in the house and which one goes on the outside. (17) Simplify x to the 8th times x squared. What rule are we using here? Because we're multiplying with similar bases, what rule will that be? we have product rule. And with our product rule, we're going to add our exponents. Okay, so we're going to have x to the 8 plus 2. And what's 8 plus 2? 10. That will be x to the 10. $18, 3 squared, raised to the negative 3. Here we have our power to a power rule. Okay, and here we're going to multiply our exponents. All right, so we multiply our exponents. We're going to have 3 to the 2 times negative 3. And what's 2 times negative 3? 2 times 3 is what? 6. Positive times a negative is a negative. Opposite signs are always negative in multiplication and division. Always negative. So you're going to get 3 to the negative 6. And how do I change that negative exponent to a positive? We're going to flip it. So we're going to have 1 over 3 to the 6. And that'll be our final answer there. '19 says simplify, and we're going to keep this in exponential form. 7 to the negative 3 times 7 squared. We're multiplying, we have our product rule. And what we do with our exponents in our product rule? We add our exponents. So they have similar bases, which means we're going to have a base of 7 to the negative 3 plus 2. And what's negative 3 plus 2? You owe somebody $3, you pay them 2. 1. So our final answer will be 7 to the first power. And I put that power because it says keep in exponential form. That's what it's asking. I'm sorry, it's negative 1. 7 to the negative 1, which would be 1 over 7 to the first power, will be your answer. And 20, is this statement true? 9 is less than the square root of 98, which is less than 10. So think about that question we did earlier. We had a number that was between 9 and 10, okay? So to do this, one is in square root form, the other two are not. So to change these to look like this, what's 9 squared? It's 81, because 9 times 9 is 81. Same thing with 10. 10 squared is 100. So I know the square root of 100 is 10. So is the square root of 98 between these two numbers? Mm-hmm. Yes. So this statement, it is true. Yes. Make sure you take tall pass. So your common assessment will be, let's see, Monday. All right, so make sure you log on when we have class. All right, we'll do our common assessment. Does anybody have any questions? I'm going to assume my answer is no.